It's a pleasure for me to introduce Joseph Ramirez, who's defending his master's thesis today. Joseph came to Cal Poly. 2023 was when he graduated. It must have been 2019 when he started. Got his bachelor's degree in plant sciences with a concentration in fruit and crop science and a minor in ag business. His hometown is in Watsonville, and he grew up on really farming strawberries with his family. So that's a great background to come to the Strawberry Center and do some research. A lot of our students now are coming from urban environments where they have very little exposure to agriculture. So it used to be the norm that people that went into agriculture came off of farms and then studied it. And then it started to switch over. My generation, for example, and this applies to me as well. I did not come from a farm, but my parents did. So, there was an exodus from the farm, and there's relatively few people like Joseph who are able to actually continue on in that tradition. I think it's a fantastic tradition. So I often wondered if I had grown up on a farm, if I would have stayed on the farm or if I would have left the farm. I think I would have stayed because I really like agriculture. And I actually fought a stream to get back into it. So, so Joseph actually got a head start on his master's degree because he started thinking about it as an undergraduate, started working with us here, and could see an opportunity and said, I'd like to stay on and do a master's degree. So he got almost a year head start on his project, which is really great, and helped him actually then land a job with us. So when he's done here, we're going to keep seeing him. He's now our farm manager, and so he's learned a lot along the way, both in terms of research and farming, I think, and eventually he hopes to go back home and work with his father farming strawberries. So it's a very unusual set of circumstances for Joseph. So we're excited to hear about the 2 years of work that he did. And he studied 3 different topics: resistance to Macrophomina, Verticillium in strawberries. It's a root rot pathogen. Then Verticillium wilt. Looked at cultivar resistance or genotype resistance in both of those. And then he also did a 2-year project on Botrytis. Both of those were an extension of other people's work. So he carried on a project that Yu Chen started in Botrytis and with Macrophomina and with Verticillium, but he's added his own twist to both of those. And so you're going to see that today. So with that, Joseph, all yours.
First, I want to thank everyone for coming out and watch me present on my thesis. I really appreciate you taking time out of your day to be here and support me. Today, I'll be presenting on my project titled Improved Management Strategies for Botrytis Fruit Rot, Macrophomina Root Rot, and Verticillium Wilt in California Strawberry Production. My 3 advisors are Dr. Gerald Holmes, Dr. Shashika Hawavitharana, and Dr. William Pericek. I first want to start off by giving everyone some background on the California strawberry production. California produces 90% of the total U.S. Strawberries across the nation, and it's valued at $2.9 billion. So this is a huge commodity in the state, and it is very important. It's a very important crop in California. There are 3 main regions that strawberries are grown in. We have the Watsonville Salinas area, and then south of that, we have the Santa Maria area. And then south of that, we have the Ventura Oxnard area. These are the 3 main regions that where strawberries are produced along the Central Coast and throughout the whole state of California. There are 2 main productions in California, the first being fall planting. This is held in all 3 regions, in the Watsonville Salinas area, Santa Maria, and Ventura Oxnard. And then we also have another season called summer planting. This is exclusively only done in the Santa Maria and Oxnard Ventura area, not in the Salinas Wattsville area. Strawberries, as you can tell, are very important in California, and growers face many problems throughout the season. One of the problems that I'm going to be focusing on are strawberry plant diseases. Strawberry plant diseases can occur on the leaves, the fruit, and also on the crowns and roots. Today I'll be focusing on three strawberry diseases up on your screen. We have Botrytis fruit rot, Verticillium wilt, and also Macrophomina root rot. So I'll be following this thesis outline. I'll first be talking about the Botrytis fruit rot survey, and then go into the Macrophomina root rot and Verticillium wilt cultivar and elite breeding line evaluation trials. All right, now getting into the Botrytis survey. I'm sure many of you guys have seen Botrytis fruit rot before, whether that's in a clamshell at the store where you're starting to notice that a couple of berries are starting to get rotten, or you left a clamshell in the back of your refrigerator for a little bit too long and you're starting to see some fuzzy growth on it. That is most likely Botrytis fruit rot. Botrytis fruit rot is caused by Botrytis cinerea, and it is the most economically important fruit rot in strawberries. It causes a lot of yield loss. Sorry, the screen's going a little crazy here. Okay, I think we are good. So Botrytis fruit rot is the most economically important fruit rot in strawberries. It infects the flowers and fruits, which leads to reduction in the yield. It affects both in the field and also during post-harvest. The primary infection occurs on the flowers, so it's important that growers are applying fungicides when the plants are actually flowering. And as you may know, flowers are constantly being produced throughout the season, so multiple fungicide applications are needed to reduce the amount of Botrytis fruit rot in the fields. The optimal conditions for Botrytis are between 62 and 77 degrees Fahrenheit. And when you combine that with prolonged free moisture of more than 13 hours, which can be caused from fog, heavy dews, or rains, that is the cause for Botrytis fruit rot to infect a flower and or strawberry. Growers have a couple different management methods that they rely on. The first one that I'll be going through is through chemical management. So fungicides, as of right now, are the most effective tool that growers have. It is a tool that needs to be constantly applied throughout the season. And I have included a label from one of the products that growers are able to use, Captain 80 WDG. Fungicides, again, have to be applied when flowers are present to see a lasting effect throughout the season. Another management method that we see is through cultural management methods, which would be consisting of disposing of any rotten fruit that's in the field. So making sure that when you're picking through the field, you are disposing of any fruit that has a Botrytis fruit rot on it. If you leave it out in the field, it can affect other healthy strawberry plants. So it's very important that you keep your fields as clean as you can when it comes to removing the fruit. Another cultural management method is adjusting the planting spacing. If you increase the spacing between the plants, you are increasing airflow, therefore reducing the chances of other infected fruit touching a healthy fruit, and also decreasing leaf wetness duration just because it has more time to dry out and thus not leaving the leaves as wet for longer periods of time. So as I mentioned before, fungicides are the most effective tool that growers have. They are applied frequently throughout the season. In the survey, we saw that there were 15 applications on average applied per season at 12-day intervals. So this is a lot of applications being applied throughout the season. The risk for this is we can see fungicide resistance to these fungicides that are being applied. The likelihood of a fungicide, of the pathogen becoming resistant to the fungicide increases as you apply more fungicides throughout the season. Another potential risk and or problem with making as many applications as 15 applications per season is the cost. It costs a lot for a grower to spray when you have hundreds and hundreds of acres. We asked a grower and they said it costs anywhere from 80 to 100 dollars per acre per application. So if you have 100 acres of strawberries, you are gonna apply 15 fungicides in one season. That could definitely add up throughout the season. And if you have more, it just keeps on increasing in terms of the amount of money you're putting into it. So one tool that was made to reduce the amount of fungicides being applied is the Strawberry Advisory System. And this was created by the University of Florida. It's a system that allows growers to look at real-time weather data to see the high or the risk for Botrytis fruit rot. So it gives you a real-time example of whether you should or shouldn't spray for Botrytis fruit rot based off of the weather in real time. This has been used in Florida, South Carolina, and the Mid-Atlantic regions. And we have seen in experiments that when growers are using the Strawberry Advisory System, it can reduce fungicide use without compromising yield from 18 to 50%. So that is a huge cost that growers are saving. Reducing your fungicide use by 50% can be a lot of money saved at the end of the year. We have a map up here that shows where each of the Strawberry Advisory Systems are. The circles are where the systems are themselves, and we have A and B. A represents anthracnose, and B is Botrytis fruit rot. And the different colors represent the different risk factors. So if you see red, that means it's a high risk for Botrytis fruit rot. If it's yellow, moderate risk. If it's green, it's a low risk. All right, now going into the Botrytis fruit rot risk factor, two weather measurements that we looked at to calculate the risk factor for Botrytis fruit rot is temperature and leaf wetness duration. We have a weather station up here. This is one of the weather stations at field 12. And at the bottom circled in red is the leaf wetness sensor. This sensor lets us know how long a leaf is wet for. And then at the top, that is another part of the weather station that collects precipitation, temperature, humidity, and so on and so forth. But we'll only be looking at temperature and leaf wetness duration. In the center of this slide, we have what it would look like if you were to graph out the risk factor for a couple months. We have the infection index on the vertical axis. It ranges from 0 to 1. And then we have high, moderate, and low risk for Botrytis fruit rot. Low risk is anywhere from 0 to 0.5. Moderate risk is 0.5 to 0.7. And high risk is anywhere from 0.7 to 1. So for moderate risk, when you have a leaf wetness duration anywhere between 14 hours and 18 hours, and temperatures between 62 and 77 degrees Fahrenheit, that is considered a moderate risk for Botrytis fruit rot. A high risk would be considered when the leaf wetness duration is greater than 18 hours and the temperatures are between 62 and 77 degrees Fahrenheit. With all that being said, we have made an experiment to look at whether it is appropriate that these growers are applying at such a high rate of fungicides throughout the season. So we made an experiment to look at these two objectives. The first objective is to compare Botrytis fruit rot incidence in the fungicide treatment in a fungicide treated area or the grower standard, and then also a no fungicide treated area. And then the second objective is to evaluate weather data under the model of the Florida Strawberry Advisory System. And we'll take a look at that right now. We'll go into the actual experimental design first. So here are the different sites that we used in Santa Maria. We had 3 fields in 2023 located marked with red. We had field 1, field 12, and field 31. And then marked in yellow, we had field 1, field 11, and field 20. The yellow markers are 2024, and the red markers are 2024 or 2023. At each of these sites, we had the cultivar Monterey planted, and we also had the weather stations along with the 2 treatments of fungicide versus no fungicides. So it was a challenge at the start of this experiment to figure out how are we going to get a no fungicide treatment in a grower's field. It's asking a lot for a grower to not spray a whole entire field. So we asked the grower to not spray only 7 beds. So it's about 0.2 acres of land that's planted and that we're asking them for them not to spray. And then the rest of the field, they can spray as normal in terms of fungicides applied. And then one thing that we did to make sure that the growers weren't spraying the no fungicide sections was put up signs for the applicators to see that says, do not spray, this is an experiment. And this was done at each of the fields. Whether it was a sign or flags, the applicators knew not to spray any fungicides for Botrytis virat in those 7 beds. So we had 2 assessments done at each field. We had in-field assessments, which consisted of me going out to the field and picking the day before the harvest crews came, and picking from 4 spots in both the fungicide and no fungicide treated areas. And we collected 50 fruit in all 4 spots for a total of 200 fruit. 200 fruit from the fungicide, 200 fruit from the no fungicide treatments. And we collected the fruit in these trays with dividers. Each side of the tray represents a replicate. So once we had 2 trays, we would bring them back to the lab, remove the calyx, and look for any Botrytis virat lesions. And then using the equation at the bottom, that's how we calculated the Botrytis virat incidence. The second assessment is post-harvest. So the post-harvest assessment was done also weekly. I'd go out to the field once a week to when the growers were picking, and they would set aside 2 trays of strawberries from the fungicide treated area and 2 trays from the no fungicide treated area. I would then take these 4 trays, total 4 trays, back to the cooler, store them at Cal Poly at 34 degrees Fahrenheit for 7 days. And then on the 7th day, we'd bring them back into the lab and remove the calyx and look for any Botrytis virat lesions. And then once we have done that for all the clamshells, we use the equation at the bottom to determine the Botrytis virat incidence. Now getting into the results, just due to time, I'll be going over 2 fields. The first field is going to be in 2023 at field 1, and the second field is going to be field 20 in 2024. All right. This is the field 1 post-harvest Botrytis virat incidence. We have the dates that what the post-harvest was collected on the horizontal axis and the Botrytis virat incidence on the vertical axis. I first want to show everyone the fungicide treated areas. From the graph, you can see that it stayed relatively low. It didn't get past 20%. And for the majority of the season, we saw it below 10% in the fungicide treated area. In the no fungicide treated area, we saw it have a higher Botrytis virat incidence compared to the fungicide treated areas, with some spikes in July and also in May. So the key thing that I want to point out is that we did see a lot more Botrytis fruit rot in the no fungicide treated area compared to the fungicide. And we see that consistently throughout the rest of the field, as I'll show you in the next slide. So now looking at the in-field Botrytis fruit rot incidence, this is where I would go out to the field and harvest the day before the harvest crews came and picked strawberries. This is the fungicide treated area. Again, relatively low. For the most part, it stayed below 10%. And here is the no fungicide treated area. And as you can tell, there were a lot higher incidences of Botrytis fruit rot in the no fungicide treated areas. So now I want to show everyone the risk factor that was associated throughout, or that was shown throughout the whole season. So this is the same graph. It's the in-field Botrytis fruit rot incidence. And here is the risk factor located marked with a dotted line. So as you can tell, we have a lot of high risk early on in the season. And once we get past June, we see it kind of mellow out and go more into the low and moderate risk factors. And then a high spike at the end in August. So with this risk factor taken into consideration, we wanted to compare what the grower actually applied out in the field, and then also what the strawberry advisory system suggested to spray. The growers actually sprayed 16 times throughout the whole season, and the strawberry advisory system suggested that they should spray 15 times. So many of you might be asking what triggers a predicted spray based off of the strawberry advisory system. Well, anything that shows a risk factor of 0.5 or higher, that is a suggestion to spray for Botrytis fruit rot. Now going into the next field, field 20. This is the post-harvest assessment that we'll be looking at. Here's both the fungicide and non-fungicide treated areas. You can see in May and April, we had a high amount of Botrytis fruit rot incidence in the no fungicide treated area. It was above 40% on May 2nd and above 25% on April 18th. And one thing that I want to show everyone, if it lets me, is that there was a difference at the beginning of the year between the no fungicide and fungicide treated areas. And then as you go later on into the season, where there was a lower amount of Botrytis fruit rot incidence, there wasn't much of a difference between the two treatments. This is the infield Botrytis fruit rot incidence. Again, it shows the same thing where when you have high Botrytis fruit rot incidence, there was a difference between the fungicide and no fungicide treated areas. And then as you go later on to the season, you don't see that difference as much. And there's a couple instances where the fungicide treated areas are higher than the no fungicide treated areas. And this is the same graph for infield that is showing the risk factor throughout the season. In this field specifically, we didn't see as much variation compared to field 1. We saw a couple spikes throughout the season, but for the most part, it stayed in the moderate to low risk factor. And comparing what the grower sprayed and what the strawberry advisory system actually suggested, the grower sprayed 9 times, and the advisory system suggested 10 sprays. So again, pretty close to what the system was suggesting. And it is awesome and great to see that the grower isn't over applying and or under applying. So now looking at the data as a whole, in 2023, I took the averages from all 3 fields. And as you can see that the graphs show there was a statistical difference between the fungicide and no fungicide treated areas in both in-field and post-harvest assessments. In 2024, we saw the same thing. There was significant difference between the two treatments of fungicide versus no fungicide. But as you can see, there was a lower Botrytis fruit rot incidence in 2024 compared to 2023. This was most likely due to the fact that in 2023, we saw more rain events occur throughout the season, while in 2024, we didn't see as many. So that's why we potentially are seeing a higher Botrytis fruit rot incidence in 2023. So in conclusion, we did see a high Botrytis fruit rot incidence in both years, ranging from 2.5 to 7.7 in the first year and 2.1 to 7.2 in the second year. And we did see that fungicides do have an effect on Botrytis fruit rot incidence compared to a non-treated treatment. And it's important that growers are using fungicides as a tool and seeing that it is actually having an effect. So that's what my data is showing. And then the second part that I want to make is making fungicide use decisions with strawberry advisory system in California fields should be further tested. It's important that growers are given the tools to apply fungicides when necessary. As of right now, California does not have a tool like Florida to suggest when they should and or shouldn't spray for diseases such as Botrytis fruit rot. So I suggest that the next step to take is to test this out and compare what the strawberry advisory system would suggest compared to what a grower standard practice would be. So now I'll be going into the second part of my thesis, the Macrophomina root rot and Verticillium wilt cultivar and elite breeding line evaluation trials. So give everyone a little bit of background about Macrophomina root rot. It's caused by Macrophomina fasciolina, and it's favored by high temperatures and low soil moistures. And then it also has a wide host range of 74 confirmed hosts. And one of the trickiest things about this disease is that it produces macrosclerotia, which can survive in the soil for up to 15 years. So it persists in the soil for long periods of time. And even if you are to fumigate, there is a chance that the pathogen will still be alive and present and infect the strawberry plants. Now, some information about Verticillium wilt. It's caused by Verticillium dahliae. One thing about strawberries is that it is rotated with lettuce, and lettuce is actually a host of Verticillium wilt. So when you plant lettuce and it gets infected with Verticillium wilt, and you are done with the crop and you work it into the ground, you are putting more of the actual pathogen into the soil. Verticillium wilt does have a wide host range of 200 confirmed hosts. And again, this disease also produces microsclerotia that can survive in the soil for up to 15 years. The one thing that I want to point out to everyone is that these two diseases are present in all three growing regions and are important. In the Watsonville-Salinas area, Mary Steele, a former grad student, did a survey to see which pathogens were in the growing district. And out of the fields she surveyed, she saw that 22% of the fields had Verticillium wilt and 30% have had Macrophomina root rot. In the Santa Maria district, we saw Macrophomina root rot occur in 53% of the fields that were sampled, and Verticillium wilt was 13% of the fields that they sampled. And then a new survey that was done by Sam Samard, done in the Oxnard district, found that 9% of the fields she sampled had Verticillium wilt, and 68% of the fields had Macrophomina. So this disease is present throughout all three growing districts, and it's important that growers have tools to ensure that they are ensure that they are producing strawberries and not having the plants being killed from these diseases. So one route that growers and the strawberry industry has taken into consideration and are running with is host plant resistance. Due to fumigant regulations, growers have really relied on host plant resistance to these different diseases. This is the University of California strawberry cultivars. These are all publicly available to growers. And they have their own scale of resistance to and susceptible to different pathogens. One being the most resistant and four being susceptible. As you can see in the table, we have no cultivars provided by UC, the UC program that are completely resistant to these two diseases, Macrophomina and Verticillium wilt. So it's important that we are continuing to look for hosts or cultivars and elite breeding lines that are resistant to these diseases. So that goes into my second project. The objectives of this project is to evaluate the susceptibility of strawberry cultivars and elite breeding lines to Macrophomina phaseolina and Verticillium dahliae in the 2023 and 2024 season. And then also to investigate the use of drone imagery in resistance screening for multiple cultivars and elite breeding lines. Getting into the setup of my trial, there were 63 cultivars in both years in both the Macrophomina and Verticillium trial, and we had 4 replicates in each of the fields. Each cultivar were planted in 20 plant plots, and they were all planted on November 1st in 2022 and November 2nd in 2023. The trials were held in 2 separate fields. The Verticillium trial was held in field 25, and the Macrophomina trial was held in 35B. Another aspect of this trial was we either had naturally infested pathogens and or artificially infested pathogens. In the Verticillium trial, there's a natural infestation of Verticillium dahliae in field 25. In field 35B, we did have to artificially infest the field with Macrophomina phaseolina. And then observations were done every 2 weeks, alongside with drone imagery that was also done on every other week once the plants were established. So now getting into each of the trials, I'll first be talking about the Macrophomina trial. This is field 35B where the trial was held both years. One thing that I said earlier was that the Macrophomina trial had to be artificially infested with the pathogen. I created a cornmeal sand mixture that was used to infect the plants with Macrophomina phaseolina. Each plant got a tablespoon or about 5 grams of this inoculum placed around the crown and then covered up 2 weeks after planting. And this was to ensure that the pathogen was present throughout the season for the evaluation. So field observations were done every other week after the plants have been established. So field observations consisted of me going out to the field, looking for any dead plants, and then bringing them back into the lab and processing the petioles, crowns, roots, and plating them on semi-selective media and see if the pathogen was present. At the top, we have Macrophomina phaseolina, and at the bottom, we have Verticillium dahliae. Getting into the results, for 2023, this is a graph that shows all the cultivars that were included in the 2023 Macrophomina trial. We have the cultivars on the vertical axis and the plant mortality on the horizontal axis. The average plant mortality for this year was 38%. We had a range from 5.1 all the way to 81.3% mortality due to Macrophomina. So it is a pretty wide range for this year. Some cultivars that I want to highlight are Monterey. Monterey is the most used cultivar in California. And it was kind of in the middle of the pack out of all 63 cultivars. Another cultivar that I wanted to highlight was Fronteras. This is a short day cultivar that is used in summer plantings. So in the front in Santa Maria, Oxnard, Ventura area. And as you can see, it's at 26.3% mortality due to Macrophomina. Another set of cultivars that I wanted to highlight are the UC Davis breeding program cultivars that were recently released. We had Keystone, Eclipse, Surfline, Golden Gate, and Monarch. All of these were cultivars that were released within the last 3 years. And I just wanted to showcase where they lined up against other cultivars. So we had Keystone that had the highest amount of percent mortality due to Macrophomina. And at the bottom, we had Monarch. So this is the same graph, but it is separated by breeding program. We asked multiple breeding programs to provide genotypes from their selected sources. And we had Driscoll's this year, Planasa, Good Farms, Plant Sciences, Crown Nursery, Lassick Canyon, and University of California. And as you can see, there is a wide range in even the breeding programs. We have some breeding programs that have lower ends from 5.1 to 81. Driscoll's was 20% to 67%. So they do have a wide range within the breeding program and the plant material they gave us. So going on to the next year's data in 2024, the average plant mortality was lower, 27.9%. We had a range of 6.5% all the way to 58% mortality due to Macrophomina. And again, I want to highlight these well-known cultivars, Monterey and Fronteras. Monterey, again, is still in the middle of the pack compared to the 63 cultivars tested in this year's evaluation, and Fronteras was towards the bottom. And then also highlighting the same newly released cultivars by University of California, Keystone, Eclipse, Monarch, Surfline, and Golden Gate. Keystone was still at the top, showing the highest percent mortality due to Macrophomina. And this year we had Golden Gate showing the most resistance to Macrophomina instead of UC Monarch. This is the same graph again, but it's by breeding program, just to show that each breeding program does have a wide range of both susceptible and resistant cultivars. Now getting into the drone imagery that was used. Again, a drone was used every other week to take images and collect different data points. The data point that I'm showcasing here is NDRE, Normalized Difference Red Edge Index, which is a plant health measurement that tells you how much the plant is getting stressed. So we were struggling a lot with finding the right metric to use to determine which cultivars and or genotypes were resistant. So we had to, one, work a lot with aerial plot to figure out what the best method was. And two, this is the first year we were doing it, so a lot of trial and error was done. In my thesis, I decided to use NDRE, area underneath the curve. The only downside with this is that it wasn't correlating with what I was seeing on the ground. We had cultivars that were considered resistant to be on the lower spectrum of the NDRE area under the curve. For instance, we had Monterey, which is on the lower end of this graph. The top right are the cultivars that are considered the healthiest, and the bottom left are the cultivars that aren't. We noticed that the plant science varieties were favored in the NDRE area under the curve. This was most likely due to it being bushier cultivars and not really the actual plant health itself.
The actual box and whisker represent there.
So the box and whisker represents the NDRE area under the curve for the whole season.
From the very beginning to the end.
Once they started collecting data, so like around 2 weeks to a month after the data, after the plants got established. So now comparing both 2023 and 2024 years. In both years, we had 35 cultivars that were included in the 2 years that I was doing this trial. So this is the 2023 year that had the 35 cultivars. And then in the next year, in the orange bars is the 2024 year. As you can tell, there is some variability between whether it was high plant mortality and or low plant mortality. We have some cultivars like 12243 show similar plant mortality between the 2 years, but then we have other cultivars like UCD Moxie that shows high plant mortality in 2023 and a lower plant mortality in 2024. So this goes into question, why are we seeing differences? Well, one, weather plays a factor into whether the plants are being infected with Macrophomina. And two, it's important that we are testing these different cultivars and leaf breeding lines throughout multiple seasons, because as you can tell, it's not going to give you the same results every single year. All right, going into the Verticillium trial, this was held in field 25. And here is the data for 2023. We had an average plant mortality of 18%, a lot lower than the other 2 trials. We had a range from 46% all the way to 1.3%. And the cultivars I wanted to highlight again are Monterey and Fronteras. Monterey again is still in the middle of the pack. Fronteras is at the bottom. And then the UC Davis cultivars. As you can tell, they all are lower than the Monterey, showing that it is more resistant to Verticillium than one of the most used cultivars in California. And then here's the same graph, but it is separated by breeding program. Again, showing a wide range within each breeding program, resistant and susceptible cultivars. So this year, in 2024, we saw a higher plant mortality due to Verticillium dahliae. We had 31.8% compared to the previous year, which was 18%. So we had a range from 2.1 all the way to 84.3% mortality due to Macrophomina, due to Verticillium wilt. We had Monterey towards the bottom this year. It wasn't really in the middle as was seen in the previous year. And Fronteras was above that. So again, this showcases that every year is different. And when you have a higher plant mortality due to Verticillium wilt, you might see a difference between where they line up against other cultivars. And here are the UC Davis cultivars that I mentioned before. And one thing that I want to point out is that it's no longer all the cultivars are lower than Monterey. We have some cultivars that are above it, and we only have one, which is Eclipse, below it. Where in the previous year, all of these cultivars were more resistant. So again, this is just showcasing that every year is different, and it's important that we continue to do these screenings every year to make sure that we get a full understanding of which cultivars are resistant and or susceptible. Here is the same graph, but it's by breeding program again. We can see that it's still following that same trend. We have both resistant and susceptible cultivars. And then here is the aerial plot graph, box and whisker graph. Again, it's the NDRE area underneath the curve, and it still favored cultivars that were bushier. So that's something that we're still working with AeroPlot to figure out the best way to screen out resistant cultivars for both Macrophomina and Verticillium. And Monterey still was towards the bottom third of this graph. So again, we did a comparison of the cultivars that were in both years. We had 35 different cultivars that were shared between the 2 years. In 2023, we had a low Verticillium wilt plant mortality, but in 2024, there was a higher plant mortality. And as you can tell, the difference was a lot greater in some of the cultivars. We have a couple cultivars, like you see Eclipse, show that it was higher in 2023 than in 2024. But if we go all the way to Victor, you see that 2024 had a higher plant mortality than in 2023. So again, this is just showcasing that every year is different. It's important that we continue these screenings because you're not going to get the same results every single year. So in conclusion, there was a wide range of susceptibility among genotypes for each trial. The drone imagery still needs to be fine-tuned. It's still an ongoing process. The next student will be working with AeroPlot to figure out the best way that they can use drone imagery to select resistant cultivars. And again, ongoing resistance screenings for new entries are important. Not every year is going to show different results, and it's okay that it shows different results, but we need to figure out which cultivars are resistant and or more susceptible to these pathogens, because these pathogens are abundant and apparent in all 3 growing districts. So I'd like to acknowledge all the nurseries and breeding programs, Crown Nursery, Good Farms, Driscoll's, Plant Sciences, Lassen Canyon, Planasa, and UC Davis. I'd also like to thank Central West for providing the fields to do our Botrytis fruit rot survey, along with the different ranch managers that helped me along the way. And then also the Strawberry Commission for funding the projects. And then lastly, the Strawberry Center for taking me on as a grad student and executing these projects. I'd also like to acknowledge my 3 committee members, Dr. Gerald Holmes, Dr. Shashika Ritharana, and Dr. William Turacek for giving me advice throughout the 2 years of my experiment and also mentoring me with my time here. And then lastly, I want to thank everyone at the Strawberry Center, all the undergrads that helped me go to Santa Maria, pick berries, collect fruit, Kyle, Colette, Allison, Sam, for being supportive throughout these last couple of weeks, and all the previous grad students and current grad students, Maria, Marina, Cooper, Mary, Jack, Yu-Chen, they all have helped me throughout my time here. And I really appreciate everybody's help throughout my 2 years at the Strawberry Center. So with that, that concludes my presentation, and I can take any questions if you all have any.
All right, we have a few minutes for questions for Joseph about his thesis research. Who would like to go? Yes.
Yeah, Shayla.
Keystone out in field 25. Do you believe that it's a susceptibility to both Verticillium, especially and Macrophomina, plays a role, or would you still recommend planting Keystone over alveol? And do you believe it's a susceptibility, I guess, outweighs its marketability in size and flavor?
Yeah, so she was asking about the cultivar UC Keystone, and if we are considering planting that in one of our fields, and if I still am considering that cultivar. Well, for our purposes, it's a little bit different. In field 25, it is a slower process out there, and it gives a pretty vigorous plant in 25, and it does really well out there. So yeah, we are still considering it. But in terms of if it were a grower asking me, I would point them in the direction of, well, let's look at the fruit quality. How's the fruit size? What's the shelf life like? And then also after that, we'd look into the resistance and see which pathogen they are dealing with in their field and see if it's lining up with what they are needing out in their, acreage. Yeah.
Any other questions?
Steven.
Kyle, and then Steve.
Steven can go first.
No. It's okay, Kyle. Go ahead, Kyle.
All right. First, I just want to say, nice job, Joseph. I think all the master students that have come through the Strawberry Center, your project was probably had the most data behind it. So I think that's just a testament to your dedication and work ethic here at the center that your advisors were able to pile on kind of a deeper look into your project. So really nice job of presenting that. My question is on the Botrytis data. You talked about the advisory system and how the number of sprays that the system was recommending kind of lined up with what the grower ended up doing. Did the timing of those sprays line up, or was this kind of the average of the season? I'm curious to see if the grower actually sprayed at the same time that those weather stations.
Yeah.
The system advised.
Yeah, so the two fields that I showed are the two fields that kind of closely aligned with the advisory system prediction. I'd have to look and see if they were exactly applied at the same time. I'm sure there were a couple times where they did apply at the same time that the strawberry advisory system suggested, just because growers are aware of, heavy dews, rains. It'd be interesting to see the correlation between when they sprayed and if we did see a lower botrytis fruit incidence. But yeah. Overall, we just kind of looked at the amount of fungicides applied compared to what they were suggesting. And I'd have to look into details about whether they applied at the same time as the suggested strawberry advisory system.
And were you able to look at any statistical analysis if there was differences between the non-spray berries and the grower standard berries, or are you not throwing stats on that just based on the data collection?
So are you asking if I were to look at the strawberry advisory system and suggestions?
Or no, if the two treatments you had, if you could see if they're statistically different.
Oh, yeah, we were able to see that there was a statistical difference between the fungicide and no fungicide treated areas for both infield and post-harvest.
Was that just generally throughout the season or at each of the evaluation days?
So for the average across the three fields, we saw that there was a significant difference. In terms of each field, I'd have to look into whether they were statistically different, but based off the average, I'm fairly confident that there was a difference between the fungicide and no fungicide treated areas. Yeah, it was on, I did show that up on the slideshow. Yeah. See if I can go back. Oh, well, I guess it's, I guess you can just follow me, Colette.
Clicker, right?
Yeah. Here we go. So, oh yeah, you're a little behind. Next, yeah. So this is the average across all three fields for 2023 and 2024, and there was statistical difference between the fungicide and no fungicide treated areas. Even when we did see a lower botrytis fruit incidence in 2024, we did see that difference between the two treatments. But I'd have to look into each field to see if that's consistent throughout both years and in each field.
So we'll go back to it where you show each date, just a single field, infield.
Yeah, this is infield. This is fine.
So yeah, you can see sometimes there's a massive difference. And
Yeah.
Sometimes
if we did each date, I'm sure there'll be a lot less areas where there wasn't statistical difference, but in some cases, like Dr. Holmes was saying, at the beginning of the year, we did see we could potentially see a statistical difference for the fungicide versus no fungicide treated areas.
Stephen?
So my question was also Ramirez trial. I was wondering, like, there were a few instances where it looked like the sprayed side of the field compared to the non-sprayed actually had higher incidence of Botrytis. I was wondering if you could maybe like elaborate on maybe some of the factors causing that, or just observations you saw that might explain some of this.
Yeah, so Stephen was asking why there might be higher Botrytis fruit incidence in the fungicide treated areas compared to the no fungicide treated areas in certain weeks. Well, a previous grad student actually did a similar study, and she saw that there were instances where she saw fungicide treated areas have a higher Botrytis fruit incidence than the no fungicide treated areas. What I have to say on that is that it depends on the risk factor. You will see a bigger difference between the two treatments if you have a high risk and a high amount of Botrytis fruit rot. And if you have a lower Botrytis fruit rot incidence and a lower risk, you may not see that difference as clear. So that's why you might see a little, flip in whether it's higher in the fungicide treated area versus the no fungicide treated area.
What about what was sprayed?
And then you also have that aspect. If the grower sprayed something that, isn't as effective, you could also see that as well.
What if you had, not this particular chart, but sometimes you said that whenever it's in the high range, that would trigger a predicted spray.
Mhm.
But sometimes it's in the high area over and over again, not separated by very many days.
Yeah.
You might have a week where 6 out of the 7 days you have a high and you can't spray every day.
Yeah.
So what is it predicting? Is it predicting for a whole week? Is it predicting 6 sprays for that week or just one?
So
How do you manage that?
the way that you manage a span of high risks, let's just say it is a whole week of high risk, you are expected to spray at least one of those days, not every single day. So ideally you'd want to spray like this. Ideally you want to spray at the high risk, and the strawberry advisory system does take into account forecasting. So in an instance where in May you see a high risk factor, right? You might see the strawberry advisory system suggest, oh, it's going to all be a high risk for the next couple of days. So that's when you would want to spray early at the high risk, and then that will last for about 7 days. It's not suggesting that you spray every single one of the days. It's just suggesting that it is a high risk. You are getting multiple potential spray events. So spray at the beginning of the season. Yes.
It's not necessarily suggesting spray or not. I mean, how did you calculate the sprays? Is that telling you to spray or not? Is this telling you the risk for that day, correct?
Yeah. So
when you tallied your sprays, did you tally 6 in a row, or did you just, given Gerald's example?
So the way that it should have been done is that it is tallied as a 7-day interval. So if there's 7 days and 3 out of the 7 days said you need to spray, that counts as one spray for the week. If that makes sense.
And say it should.
Yeah.
That's the way you did it.
That's the way that I did it, yeah. Based off of the amount of
So over a stretch like this,
Mhm.
you might actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, 10 spray days.
But if it spans 3 weeks, that's only 3 sprays.
Correct.
Not 10.
Correct. Yeah.
Because I'm looking at that graph and notice, that the x-axis is a category, right? 11th of May, 17th of May, 24th. I don't know how the risk factor is. As a continuous variable over time, I'm not sure how you. I don't know how that line works.
So that line is lining up with the dates that are seen at the bottom. Is that what you're saying? Is that what you're
That's
asking?
what I'm asking, but I mean, it's the line, right?
Yeah.
So I mean, 11th of May, 17th of May, what's?
How often is the weather data?
The weather
I
data.
mean, in between that 11th of May, you have one that's at 5, then you have one at 45 and 50, and then back down to 15, so it's continuous, right?
You have to measure that over here.
Yeah. So
Well, even there, but I mean, but the x-axis is, it's not even, I mean, the x-axis is not even, right? It's 6, there, 7 for that day, 7, you know, and then the end, there's 10 days, so it's not like even.
yeah.
It's a category, it's not continuous.
So the way that the data is extracted is that we have risk factors for each day. And then when I was inputting that into Excel with this graph, you can adjust it so that it's, you know, a 7-day span or whatever span it is for the in-field assessment in this case. And then we line it up with those dates so that we can get the risk factor for each of the days that we collected the data. And that's why we are able to span it across the x-axis is we made sure that everything was lining up with the dates that we were actually collecting the data.
We might go in more detail later.
Yeah.
Other questions?
For the Botrytis trial, when you're comparing the fungicide and the no fungicide, do you see any susceptibilities to any other pathogens or pests than the no fungicide?
Yeah, so we did see later on in the season rhizopus and euchre in both fungicide and no fungicide treated areas. In terms of the pest, they were both the same in both the fungicide and no fungicide treatment. I wasn't scouting, but based off of what I was seeing on the field, they did have a similar pest pressure. But yeah, we did see rhizopus and euchre later on in the season in both of the treatments.
Yeah.
So in your Macrophomina verticillium
Mhm.
studies, you said you're looking at the drone imagery,
Mhm.
and you said that the drone calculations and it picked the bushiest ones.
Yeah.
Were the ones, but isn't that what you're looking at, too? Bushy versus not bushy, you know, half dead, not dead, I mean, that's what it would ultimately manifest itself as, right?
Yeah. Yeah, so
That sounds good.
we do look at, you know, kind of the foliage of the actual plants and cultivars. But the thing that we were seeing is based off of the NDRE area under the curve, the cultivars weren't lining up with the actual plant mortality. So let's just say I have a plant science cultivar that's really bushy. And because it was super bushy, it wasn't saying that, oh, it wasn't correlating with it actually being resistant. It just was a really bushy plant, and it was using the NDRE to showcase that. It wasn't necessarily taking into consideration that half the plot died. It's just that the plants were bushy, and the way that the data was divided up, if a really big bushy plant is present, it could account for 2 plants potentially because the way that the data was divided up. We had 20 plant plots, but the way that the data was extracted was each of 2 plants were in one box basically. So you had 10 boxes, and if you had, you know, a cultivar that's leaking over to another plant, you're gonna get that reading for that basically box. So that's why we're most likely seeing these bushier plants have a higher slash potentially more resistant to Macrophomina and or vert. Yes.
So does that mean that a larger plant didn't necessarily be more susceptible to Macrophomina specifically, since it's a kind of a stress-induced, disease? Because you would just think that a larger plant requires more water, everything's getting irrigated the same. A smaller plant that's requiring less water would maybe be, not as susceptible because it's not getting as drought stress. Did you see that kind of correlation, or that not really pencil out?
Based off of the data that was collected and that we used, we weren't really seeing that correlation we thought that's what we were going to see, but when we finally looked at the end of the season data, it wasn't lining up with what we were actually seeing out in the field.
I have another question about, you mentioned in the Macrophomina and the Verticillium experiments, every year is different.
Mhm.
And we knew that before you started.
Yeah.
There's something about, you gotta put some level of trust, confidence, it gotta tell you something.
Mhm.
Otherwise, there's no point doing it. If
Mhm.
every year is gonna be different,
Yeah.
and everything is just, roll the dice, and every year everything falls out in some weird pattern,
Mhm.
then there's no rhyme or reason, right?
Yeah.
There has to be some reason for doing it, and some consistency
Mhm.
from one year to the next,
Yeah.
because the weather obviously is gonna be different every year, but the
Mhm.
weather is going to affect everything that's in that experiment
Mhm.
in, I would think, a similar way,
Yeah.
not necessarily exactly the same way. But if it's a hot year, then everything in that experiment gets exposed to the heat,
Yeah.
the same heat, right? So what is it that we can take away from one, if we're getting this kind of variability,
Mhm.
what does 1 year tell us? How much confidence can we put in that? Where do you stand on that?
I think it depends on the year. In 2023, it was kind of an abnormal year, I would say. We had a lot of rain. We got the atmospheric river flooding, the Pajaro and Watsonville area. So I think we can base our evaluations on 1 year, but we have to take it with a grain of salt and consider what that year actually looked like. Because we're not going to get another, the next year we obviously didn't get an atmospheric river. So that is a totally different environment that the plants were being experienced to in the winter time. So I think it just depends on what that year looked like in terms of the whole California
So
region.
maybe we'd be able to compare it to another wet year
Yeah.
that had maybe similar levels of rain at the same time of year.
Yeah. So I think, like I said, it's important to know how the plants are going to react for, a wet year or for a dry year. Um, I believe that environmental stressors are a big part of what breeders need to be looking into. Because if the plant can experience less stress and is more resistant to, water stress or salinity stress, then we might see it be more resistant to Macrophomina or Verticillium wilt. So it's good to take into consideration whether it's a wet, dry year and look at that underneath, the whole scope of it.
So if you were advising a grower
Mhm.
on resistant to one of these two diseases,
Mhm.
how many years of data do you think you would need in order to feel confident about what you're saying about its level of resistance?
I would say at least 5 years to kind of feel comfortable
Wow.
with what you're seeing on a year-to-year basis. Um, like I said, California is such a weird state. We get droughts for multiple years, and then we all of a sudden get atmospheric river the next year. So I feel like 5 years is a good span to kind of get best of both worlds and understand kind of the way the cultivars are reacting to the different environments.
Got a lot of work to do, though.
Yes.
We've been doing this for more than 5 years, right?
Yeah.
So it continues. Any other questions? Okay.